So this is my next video update on the project which I'm going to be calling Rags to Robots. And so in the last couple days I've been working on building the first robot body, and you can see this is what it looks like. So it's basically a bunch of plausible materials that a robot could find in a landfill and be assembled from. And so we have, of course, the cardboard box head, the milk crate, pelvis, those sorts of things. And I designed kind of this blackboard style, I guess I call it like a skeleton graph area for starting to work with the robot's parts. Eventually these sorts of parts will be replaceable with various objects that you find in the environment in the game, and a lot of that will be procedural, and then you'll just be able to swap them in to replace particular parts, but you have to account for things like changing center of mass and various trade-offs. And the big question is whether the robot can generalize to the different bodies. And before, I had various working locomotion policies, but the problem is that I realized I'm going to have to generalize the gameplay to 3 dimensions. Before it was 3D, but kind of really hiding the 3rd dimension, because there was never any need to show the robot from a different angle. But due to various gameplay design constraints, it will be logical. So the reason why I realized like it needed to be 3D is because I had this idea of a world which starts in the landfill and then forks both upwards and downwards along essentially corridor or sidewalk-like constrained volumes that are branching in terms of how the world will be laid out. That's my plan, is rather than open world or fully constrained 2.5D platformer, the idea is to build a branching world where there are sort of like sidewalks that go back and forth, and constrained volumes where there is fully 3D volumes, and that's within those volumes the robot can move. And so I think that using 3D definitely brings a lot more challenges to making the game work. The big reason is because the robot can fall over a lot easier, because it can fall over sideways. And so that means that our policies have to be better, and we have to use better reinforcement learning in order to ensure that the robot is more robust to falling over, right? So these are basically policies that I recently trained tonight. And what's really interesting, so the PPO policies that have this goal, they have a goal to keep the head up and to essentially maximize the height of the head. And actually some of these were trained incorrectly to minimize the torso uprightness, so they just fall over. But these are the latest ones which were trained, and I switched from PPO to SAC, which is this paper here, Soft Actor Critic, which explores the space to find more entropy. And you can see that they have pretty interesting policies. They're not able to learn how to stand up yet, but just in a couple minutes they've at least got some pretty crazy parkour poses. Actually, a big problem is there's still a little bit of a misalignment in how the capsules relate to the robot meshes, and so there's some work that needs to be done on a editor to align those sorts of things. And but you can see that at the very least we are able to specify these various reward constraints here, right? Such as maximize or minimize, and I have various ideas here, and our rewards are mainly going to be that players can select and choose as a gameplay element for designing their neural networks for their robots. Will mainly be based on selecting various body parts and then choosing how the reward is related to vector orientation, as well as world height or world coordinates, and perhaps even local coordinates of the various robots. So there's no walker for tonight because we're just trying to build the first 3D version of the robot, which can, for one, my goal is just to get the robot to be able to stand up steady in 3 dimensions, and then 2 is being able to recover from falls to get back up and to walk. And walking in 3 dimensions is a little bit harder. But I am generally, I'm hopeful we can figure it out and make it so that you can have a modular robot body that you can have an RL policy for, that you can swap the part, and either the RL policy is robust to different body types in the way it's trained, or it's fast enough to fine-tune an existing RL policy to adapt it to your robot. And that will depend on a lot on some gameplay elements. So to tell you more about the story, the idea here, and let me give you an example, is that we have this almost like a, kind of like almost Dark Souls-like level of verticality, where there's you and you're kind of the slice of life ordinary robot that is on the landfill and tinkering level, and then below, underneath, there's caverns and dungeons, and then above there's an aristocratic robot society. And the idea is to so basically this idea emerged from realizing that you can scavenge a lot of interesting metal parts and materials and old machines, but it's a little bit more difficult to scavenge state-of-the-art computers. So there's this sense that robots, in addition to having this scavenging and adventure combat loop, they also need an alternative or additional loop to increase their social standing in order to gain capital and acquire computers for more advanced neural policies, more advanced sort of various algorithms that need more advanced computers have to be acquired from above. And of course the idea is there's different trade-offs for robot bodies, and some robots that could do well above would do very poorly in the combat scenario. But ultimately we're trying to build this game where you can build your RPG party of trash robots into adventurers and aristocrats. And that's sort of the idea behind the game, is to really support this progression fantasy in multiple directions while enabling a strong core gameplay loop of RL policy training based on player specified constraints. And right now those are simple constraints, like, as I mentioned before, the orientation and position of various body parts, and eventually that will grow more complex to include specifications in relation to particular entity type lattices. So what that might look like is if there's an entity that's an enemy, or let's just say that we query in the world for nearby all the enemies, and then we have another AI query, or really just a database or ECS query of what's the nearest enemy, and then that position, or even the further decomposition of that query, like a particular location target on the enemy's body or understanding of the enemy's body, will need to be passed into the RL policy or through intermediate inverse kinematics layers to essentially determine the robot's motion, not just in relation to its own reward system for its own body parts, but for the orientation and position and semantic nature of other entities in the world, those being integrated into the RL loop, and of course also being integrated into the future simulation loop. So that's all for tonight. Thanks.